So basically in this session what we will do is we will go for Arduino programming, introduction and all of it. As far as my interaction after the session happened, it was like some people already know it and some people don't know at all. So now we'll try to make a combination of it so that those who know should also get benefited and those who don't know should get benefited, but I think so they'll have more benefits into that because they would be working really hard on that. So what are we going to do is this would be a fully interactive session that we will have. If somebody wants to share some information from their side, we'll keep it open. We can discuss amongst ourselves. Don't stick to your seat. If you want to move around in the hall, most welcome. Let us talk to each other and understand how it works, because it's not a class that we are attending, it's an FDP, so we should be in a position to make good connections, talk to each other also, learn from others. So initial maybe 10-15 minutes I'll just take to get it used to Arduino, that's it. And then what we will do is I have got the Arduino board here. If somebody wants to come and see, they can see how it works and how we connect it also. I'll show it to you. Other than that, if you already know all those things, then it does not make sense wasting time. What we will do is we'll try to get some experiments done here and take up some example and try to solve it. And the condition is very simple. You can solve by talking to each other, by using internet, whatever sources you want to use, you use it. And let me again repeat it. This was like an added session that we have added into Arduino programming. This was not there initially. We have just done it because without Arduino programming, your IoT can work, but this is a great help. So Arduino is like a small microcontroller programming thing which can be easily programmed through your laptop, and you can gather readings from different sensors in it in a very easy way. So it actually helps you into evolving different kinds of applications, real world applications, and see how it works. So I'll not go into the history of it and all of it, but let us just get a small introduction on Arduino programming and see how it works out. This is an open source platform. The website that you are seeing there, that side website is only for the picture. This side is the main website, that is arduino.cc, and I'll surf through that website and I'll show it to you that it is really very beneficial to utilize that website. Everything is available there. The best part is it is open source. That means you can also add coding to that. Now before I go into this thing, majority of us are from electrical, then we have CSE, ECE also. See, there are different ways and approach to an application when you actually go for an development of anything, there are different approaches to it. Like when I am into a freelance programming, what will happen is my idea is to get an output, that's it. What kind of a code is there, what is inside it, I don't care, to be very frank, till the output is being reached. If the same thing is being done by a research scholar, it is totally different. He or she needs to know all the ins and out of that program, the algorithm of it, the flowchart of it, and so on forward. Now when we go for an application which is a real world application and only software is not involved, then there are more aspects to it. Now when you are working on Arduino, one is you need to connect it with your laptop, program it, then you use it wherever you want to. The point is that am I interested in the programming part? Am I interested in the construct of the Arduino board? Am I interested in what part of it? So is the construct going to change my programming in any way? Yes or no is the question that I need to ask. If it is not going to affect, maybe I can just leave it off. As a research scholar, you need to cover every part of it. Like if I'm working on a battery, it's a lithium ion battery, you need to know everything about it. How it charges, discharges, what is the chemical properties of it, what is SOC, what is SOH, what is this, what is that. Whatever you want, everything has to be covered into that. On the other hand, here the point is that, means in that, if I'm not using the hardware, it is okay. But if I'm using hardware, then I need to even know the weight of the battery. Without that, how can I work onto that? So there are different kinds of applications and different kinds of thought process into it, and the learning part also. So in Arduino, I'll say you need to decide whether you want to go into all aspects of it. As a research scholar, yes, you should do it. But still, do I need to go into the construct of it as to what this is, what that pin is, what is that, that should be known at least. But what is inside that chip, should I know? I'm not sure whether it is required or not. So if you just see here, there's a chip here, a big one, and then you have got a push button here. There is a USB kind of a thing, a kind of connector like this. So in that you give the power supply to it, and even the feeding of the code will be happening from there only. So that one is a different image. If you see here, this is Uno, and you have got a different kind of a connection here. The pins are up, which is not visible there. Probably the chip is missing, that big one, but a smaller chip is available, and so on and so forth. So if you see there, approximately similar structure, but a little bit different. So even we have got different kind of constructions for Uno as well. Ultimately, the fundamental is that if you want to make good interactive projects, you can utilize this particular thing. The benefits, as far as I have done it, I am not a master in it right now, but yes, I have done some programming and I have implemented it, so I have a taste of it at least. So what has happened is that it's simple, easy, compatible, cheap. If you don't know the rate, I'll tell you it comes at around 400 max. So it's a good cost at that. And if you add sensors and other things to that, sensors are hardly like below 100 rupees. So you can have a small project running without even going up to 1000 rupees. So in fact, yes, tomorrow also that ESP8266 that we'll see, the rate on Amazon is I think so 499. So 500 rupees, and plus you add some more material to that, you are running a project already. So that is one of the things. Cheap. Connectivity is really good. Replaceable, I'm not sure, and that is why I've written there not for all Arduino. As per my workout, you cannot just replace one board with another one in many of the cases, but in some of the cases, yes, we can do it. The voltage remains steady. You have got, anyways, the third last is not that important, but the second last is more so important for me. You have got a good community support. I'll show you the website also. It provides you with a lot of information onto that. In fact, all that you need to know is available on the website. So you don't need a teacher to teach you, right? And then I have not experienced this thing, but yes, in some cases, open source is really beneficial. So that is one part of it. Usually we have a constant voltage supply of 5 volt as far as I remember. But we can adjust the voltage levels using the different pins which are there. The pins are here. There is a set of pins here. These are the pins which will be used for interaction, and there is a set of pins here also. The different kinds of boards that we have in Arduino is actually had started at a very low level, but now they have got a number of boards available with them. So I have tried to get a collection of as many as I could. The first one is Uno. This is the most popular one, and the microcontroller that you have is Atmega 328P, and number of digital pins, analog pins, clock speed, and ideal for simple projects and learning. So we have taken Arduino R3 itself here, but that has been a little bit different. The chip is different. This is Arduino Mega. This is designed for complex projects for high memory and pins. The chip also has changed. If you just see, it is 2560 now, and the number of pins and everything has changed except for your clock speed, right? It is suitable for robotics, IoT, and large scale projects. As a beginner, I would suggest, even if you take it as a hobby, it will hardly take you 1,000 rupees to start a hobby. That is worth it, and you can just experiment with it. And anyways, I'll tell you all the benefits one by one. So you will see that once you get a knack of it, then you feel like your confidence also grows, and then you feel like, yes, I can do more. Then you can experiment some more things and implement it. So even if it is not useful in your projects and research, I would suggest at least give one hand to it and see what happens. At the maximum, you will lose 1,000 rupees. That's it, and that too on the higher side, I am saying. So we were able to get, right now, as I said, we were establishing a lab. We were able to get majority of the smaller elements at a very low cost. Sensors are hardly having some cost. The cables are low cost, and this is going to around 400, and this one that we have brought is around 410 rupees. So I assume that you can obviously give it a try any day. If not, you can, if you have children at home, you can help them run robotics on your own, and you can show how it works. So to be very frank, I came across some of the projects in Python also, which my students had made, and they had created a whole robot in which the robot moves around and senses the objects automatically for what we say, autonomous driving kind of a thing. And that student is already developing that robot. Right now it requires some battery power, so it is wired. So he's looking into the option of having it unwired. Once it is unwired, he plans to put it as a firefighting robot. The robot size is this big. That's it. So it's a good option that you have again. And then you have got an Arduino Nano also. It's very compact and friendly. And you have got, again, just a second. You have got Atmega 3 to 8P. The analog pins have gone down a little bit, but this is for like if you have space constraints, you can utilize this one. Then you have got an Arduino Micro. Don't go by the image size. I have expanded it. An actual thing, the pin and the board size will change. So here you have got a small size USB for small size board for USB functionality. If you see, the Atmega thing has changed again. The clock speed has changed, and it's the application is a little bit different here. Let me also tell you, Arduino, the website is free. Everything is free. There are other companies also who make boards which are similar to Arduino. So you can use that also, not compulsorily that you go by this itself. You can change it also. And then this one is Arduino Leonardo. This is integrated USB communication thing. The Atmega is different. Your projects requiring human interface can utilize this one. And if you see, there's Leonardo already written here. There also the specification is given there, so you can just see it there when you buy it. Right now, the version of ID, I think so I can get an answer from you. No, full form of ID. Integrated Development Environment. So as far as I could see, it is 2.3.4 right now. It is free to download from Arduino, and you can get that software from there. And once you get it, then you can load it to your Arduino itself directly. So I could even find the source code also there. So in just a second, I'll try to show you the website. So this is the website where you get the software. You can directly download it, and when you download it, you get a software. If you put it on your desktop, it will have this icon there automatically, right? So that will help you to load your programs onto the Arduino board. That's it. So you can write the program and you can upload it into Arduino, right? And right now it is 2.3.4. I would suggest that you keep it updated with yourself, so that would be helpful for you. I'll come back to this slide website again. There are a lot of things in this website which we need to explore. Let us get back to the yes. So what we have is in Arduino, the program is called as a sketch, and it will be basically divided into two parts. One is setup and loop. Setup is which will be executed once. Whatever you want to execute once will be written in the setup part, and whatever you want to get it repeated again and again and again, you will write it into loop. That's it. So basically, whenever you want to upload it, you have to connect it. I'll show you that part also. So only two functions are allowed for you to write it. Let me open that also and show it to you. Just give me 1 minute. I'll open that also. So it will look like this when it starts. And this is how you write the code onto that. So if you see here, you will find that there is a setup part here, right? And there is a loop. I am not able to see my own mouse. So here if you see, there is a setup written here. So that is the function that will only execute once, and by default you get this program with you, and there is a loop written here which is to be repeated. Okay. So the next thing is you have got this very good thing called as functions. Yesterday only I added this thing because it suddenly struck me that functions are very important. If you don't know the construct as to how it will work, we will not be able to work out properly. So let me just click it. And the best part is you have got, just a second, let me zoom it off. Yes. So if you just see here, there are a lot of functions. I'll not go into the details of it. You can just explore it and see what is there for you. One is like digital read, one is digital write. Pin mode is there to set up the mode, whether the pin is input, output, and other things. So you have got math functions also for squaring, square root at the bottom if you see, and you have got analog read. So this is when you connect it with the system, automatically these things can be utilized for gathering of the data. So there is a lot of functions, not as much as other programming languages, but yes, enough for us to run. So just go by it. So you can explore this thing again. And if I go here, there is something called as variables also. I assume that you understand what is a variable. Variable is something that can change during the execution of the program. So you have got variables, and constants means those which will not change. So in a program you can see that there is a high and a low. This is usually like when you have to get an output, you say a high. When you don't want a output, you say a low, and so on and so forth. So these are the variables and constants and other things also which are there, right? We know a little bit about byte, char, float. If you have gone through C, you already have some idea about that. And then you have a structure here. So I'll not go much into that, but if you just see, structure means like sketch is a program. Out of that you have got a loop and a setup, and other things are also there, like operators are there, and let us not go into much details. Structure means what are the facilities to write a program. So you have got a control structure like break, continue, while is a loop, else is goes with if, return, and all of it. More so like C, if you remember. And if you just go up here, it will also tell you something like yes, the elements of Arduino C++ code. So I can utilize that as well. Another one is examples. I don't think it will run, but the problem is with the mouse. So again, examples is again from the same website. I'm not changing the website. The website is same. You get a lot of examples here. So you can just see how basically you can blink a LED. You have a fading LED. So I would suggest that you first go through these examples. This will be very helpful for you as a startup kind of a thing. Then you can move ahead with the other things. And the last thing is, I don't know why it's not working. Yes, the last thing is the resources. I'll share this with you, and the link also will be there probably, so you can just go to that. And these are some PDFs which are available online directly. You can just click and go through it to learn. There is a forum also which is available on that same website, and the best part is you have got certification also available, so you can just explore that part. So that is as far as the one-way communication goes. We'll stop it here and let us go to the other part of it. Let us explore how we can learn, we can teach each other, and how we can benefit from our knowledges. So there is another website there that is called as Tinkercad. So I don't know why my laptop is giving problems. So what am I doing is I'm going to I have actually specially created a 5 kind of programs, out of which 2 I will share with you and 3 we will try to create it in the remaining 1.5 hour or 1 hour that we have. So we will try to create it from our own side. Only the question will be floated. You can talk, and by that time, like sir wanted to share some information, we can have that also, and whatever. So it would be an open stage, and as well as we can talk with each other, move around here and there, and get the thing done. Okay. So what we will do is we'll try to have a simpler one first. Once you get that one, then you go to the second one, and then to the third one. The third one that I will propose is a tougher one. Probably we can have it at different levels of completion also. So we will see that thing. So in case if you don't want to invest even 1,000 rupees, this is a good option for you to learn. Now I have already logged in. If you log in, you basically get 3 options here. One is a 3D thing, this is another one, and the circuits. We are interested into circuits right now. So I have just logged in into the circuits one, but should I give you like 5-10 minutes to, if you have, how many of you all don't have an account in Tinkercad? Like, so I'll just leave for 4-5 minutes and you can create an account in Tinkercad, and we'll again come back so that you are able to open circuits. Those who already have it can help others. It is actually, if you see, it's from Autodesk, which is AutoCAD. So you can even draw some 3D designs there for other things. So, usually we go with the simpler ones and the students do the harder ones. So I'll show you the simpler ones and then let us go to the harder ones and we'll see what can be done. So when you want to do a new one, you go to create. How many of you all are using Tinkercad for the first time? What? Oh. Long back. So maybe the design might have changed. So you go to create and you have got circuits here. And you will get a new one here. The components are here. You can just drag it and put it, right? You can, the components are here, or you can even search it out here. So Uno and everything is available here. You have got this option of writing a code here. Okay, I did not have anything. I have not done anything, right? So this is how it will look. You can give the name and you have got the code here. Now, personally speaking, I don't feel like these blocks are good enough. If you are used to it, it is okay. Otherwise, I usually shift to text because I like to write it, the program my way. So I shifted to text. So if you just 2 minutes, if you have a look, I'll be able to show it to you how it works. So if you go and add this thing here, right, immediately this code will turn on. You go to the code and now you will get this kind of a thing. I tried it once for blinking of the LED. It was easy till then, but as you go into a complex question, it becomes tough to do the thing. So I just shifted it to text. So what you do is, here you have got a block written. You just click on block and then there is text available here. So it will ask you whether you want to do it or not. You just say, I'm not able to see, but whatever it is. You just say yes and you can shift it, and again you get those two parts, loop and setup. You can remove whatever is written there and you can write your own code. So I'll show you how to write the code also. And to save it, you have to give a name here. Otherwise it will give some random names. On the top left you need to give the names. If you don't give the names, it's gone. Some random name will come in. So I will basically try to utilize what I have already done, and this was the first one that I had. You also have got a breadboard there, so you can use a breadboard also, but I would suggest that let us go slow, simple. Just get a this thing. I'll just change this. This is, I think so, 220 ohm. Right. So what I have done is, if everybody can just have a look, I'll show it to you. You can make it within minutes. If you don't know, if you already know it, no need to pay attention. So I have brought an Arduino Uno board and then I have connected it to ground. LED is there and a resistor is there. There is a reason for it having 220 ohms, which you need to have it. And what I have done is I have connected the LED short leg to ground, right? And the long leg to one of part of the resistance and the other one to D6, I think so. D8, sorry, D8. So that is it. Just make this much. You have to just click and drag, drop. Wires will automatically be created. Ma'am already knows it. If anybody wants help, she can also help you out. That would be really good. Once this is done, just let me know. So I'll show you the code also then. So you can even set up a lab if you want based on this itself. Interchat. In order to see that whatever the required amount of voltage and current will flow, then only the LED will be continuously glowing. Okay? And if at all still you require some additional amount of intensity, LED to be illuminated with high voltage, then you may have to change and increase the amount of the resistance. Okay? For a longer operation, the shortest amount of the resistance value will be supported. But for a continuous operation, depending upon our own requirements, we may have to change for different type of resistances. Okay, and initially, here you have to look into what sort of a pin structures that you are going to have. Okay, each and every pin is having a specific functionality. Not every pin will be used as an analog pin or a digital pin. These are the only analog pins, A0 to A05. These are the 6 analog pins that we have. So only whatever the analog type of sensors that you are going to connect, you can connect it over here. And when you are going to make use of a digital sensors, then you have to use the digital pins. And that too, when you are going to use the 0 and 1, you should not connect any sort of a sensor while you are programming the Arduino board using the USB cable. Why? Because the same TX and RX pins will be used for the controller when you are dumping the code into this particular board. So that is the preliminary precautions that we have to take care of. Initially, there should not be any sort of a connections that you will be establishing in the TX and RX pins. Once the code has been dumped and still you want to make use of this TX and RX pins, then you can connect any sort of a sensor and you can make use of this particular pins as a normal digital pins which can act as both input pin as well as an output pin. Okay? And specifically, these pins we call them as PWM pins, pulse width modulation. Most of our air conditioners that we are using nowadays, we are calling them as inverter ACs. So why we require that pulse width means, in order to see that the stability of the signal is continuously existing with a low one single pulse, if at all the single pulse is having a larger width, then the amount of the high voltage value that it is going to persist in will be high. So for that reason only, when you are going to make use of any sort of a component, then you may have to use this particular PW pin in order to see that the width of the pulse, if at all it suits the sensor requirement, then only it can be fixed over there. Otherwise, we cannot fix it over there. Okay? And once again, here you are having power supply which is onboard power supply which can be powered with respect to this particular Arduino board itself for all the devices that you are going to connect. All the devices here we mean that the sensor that you are going to connect can be powered by using the own onboard power supply which you are having it as both 5 volts as well as 3.3 volts. That 3.3 volts, some sensors they are very much persistent to high voltages. They can't even support for up to 5 volts. So immediately those sensors whose power requirement is only for 3.3 volts, then we can make use of the 3.3 volts onboard power supply. And here you can support this particular Arduino board using 2 different power modules. One, making use of this particular USB cable which itself, when you connect it to the system, it will work. Nextly, you can use an outbound adapter
electrical adapter will be there, no? Just like we connected with our node MCUs, sorry, network modems and all. So similarly, you can connect this particular power supply also over here, which will support up to 12 volts, not beyond 12 volts. Okay, and this component we call it as a voltage regulator. This voltage regulator, it will be consuming the 12 volts as a 9 volt, 12 volts as an input, and it will deliver two different output voltage values, which are calling it as 3.3 volts and 5 volts. So these are the two things from which your 3 volts and 5.5 volts are coming into picture. Okay, sir? Please correct me if at all I am wrong.
No, you're going right.
And one more thing is, when you are going to make use of this particular power supply, why we are making the onboard power supply itself means, in order to see that whatever the voltage that is already rectified, that is properly filtered without having any ripples, all the sensor components that you are going to make use of can make use of the same supply and see that no particular filtering is further required, and the components will not fail in any of the cases. Okay, and this is the crystal oscillator which you are seeing across here. That sir told me that 16 megahertz crystal is there. No? This 16 megahertz crystal, why we require this is like that crystal clock is the synchronizing signal among all the sensors. Yes, sir. This one. This is the synchronizing signal that will be generated, which will be used by the controller as well as all the sensory components, wherein you are to have a synchronization among all the components with respect to data delivery. Okay, and moreover, it has got an onboard LED which will be bringing out the digital I/O pin that will be 13th pin. Digital I/O pin is the 13th pin, and as said, this particular board is basically a DIP package. This sort of a lengthy IC that we are showing now, it is a DIP package, dual inline package. Okay, and there will be an onboard chip which short there is a small rectangular one, that is a SMD component. So both you can make use and you can even develop your own board structure also. Okay, and what additional things that you can have to require? Basically these are the things that you can try to work on, right? But if at all you want to have all these components removed and you just want to make use of this 328P IC only, then also you may have to use these two components specifically. Okay, I can design my own board without using any of these particular existing components on this particular chip and making use of only this and the voltage regulator. I can design my own board, my own layout, I can do whatever I want. That is what that open source means. So that 328 pin component, that itself is the costliest of the particular controller board. Okay, it will be costing around 190 rupees if at all you want to purchase it outright, and if at all you want to buy it on a board, maximum you are spending is only 400 rupees. But this will be the rugged board. This is a very rugged board. You can make use of anything, any number of times. Okay. So you are showing that Arduino mega board, no, sir? In your slide.
You want Hey, just a second. Just one.
And basically, this JIT is this one. There is a slight difference between the boards that you purchase outside. Some boards will be in blue color, some boards will be in green color, and some boards will be in red color. Yes. Some boards will be in red color. The fundamental difference between all these three boards are not only related to the controller or clock frequencies, but additionally the way we program it. Okay, the way they can operate with, the number of sensors that it can be connected with. And this Arduino mega board. This is the Arduino mega board. No? This is basically two Arduino ICs that are inbuilt with each other. Okay, so this will be having an overall of. In the initial board, you have seen only one transmitter and one receiver. But here you will be having two transmitters and two receivers. The same board can be used for performing both the transmission as well as the reception, which can be able to communicate with multiple devices. Multiple components can be interfaced. It can have a complexity of connecting a VGA graphics related device also on board, surface mounted. We can try to program it, we can try to make use of it for any of the application as if we do it in our normal desktop systems, but not that complexity, but some like text related activities. If at all you want, you can try to generate it and make use of it as a computer. Okay, and here also most of the fundamental pins that you are trying to see are one and the same. But additional pin configurations are used for supporting multiple type of devices, digital and analog. Okay? And buy it online. The one compact
Actually, sir met me and said he wanted to share his knowledge about Arduino. Thank you very much, sir. And this is the spirit of the FDP, like, we interact with each other, we talk with each other, and that was really a great amount of knowledge that you shared. On a lighter note, you cannot keep a teacher away from the stage. So, yeah.
regarding the pins, each and every pin, they will be generating only 20 milliamperes of current. That current is not quite sufficient for the LED also to glow. That will improve the current rating by using the 220 resistor.
So these are that is what I started with. These are two aspects of it. Like, sir is more interested into the actual construct of it, and yeah, please. Sorry for that. The thing is, like sir is more interested into the construct of it. There might be somebody else who may not be interested into that part, but more interested into the programming part of it only. So maybe I don't care what that thing is. I can just concentrate into programming. But again, I'll get back to it. If you are doing research, please do both part of it. So you should know the electronic part to the level that, like sir is telling you, at least if not to that level, some basic information should be there with us. And the other thing is programming obviously is what it is required. So the thing is 220, I'll give you the exact calculation also for that. I think so. If I had it somewhere, in the busyness I forgot it, but I have it. I'll share it with you. Why exactly 220, not 210, 230? Sir has already given the reason why it is required, but why that exactly 220, the calculation also is there for that. So sir, you actually added a very good color to the FDP, and I would also request, we still have 1 hour. If somebody wants to further share their anyways, tomorrow also we can do the same thing. If you have some more information and things, but just tell me beforehand. Like sir had already told me that he wants to do it, so please do it. We are most welcome, and let us share our information that we have. Then what I have done is, I have written a code here for this thing, and it looks something like this. Is it visible? No. I'll just copy it. So, this is some issue with the projector, but I think so it is visible now. I'll still try to. I'm just increasing the size of the font. The size is there, no? Oh, too big. But anyways, so this is C++ code. This is the pin mode. The pin mode is output. So it will send an output for that. Let us not go into much details, otherwise we'll lose a lot of time. And then you have got a digital write 8. This is pin number 8. This is pin number 8. High. High means it should glow. And a delay of 1000 milliseconds. Then again digital write at pin number 8 again, which we have set as output to low, and a delay of 1000. So this will lead us to a blinking of the light. So I believe, even if you don't complete the session today, the program that I give you for the last one, you can try it at your rooms somewhere. So are we getting the output then? I'll just run it. And you can see that it is blinking. Right, simple. Actually, I would suggest you can set up a full lab on this. 3, 4, 5, 8 experiments can easily be set up with no issues into that. Especially in electronics, you can easily have it. So one done. One more I'll show it to you, then it goes up to you to do the remaining part. Aish. Oh. Aish. A street light design kind of a thing. The only problem is again the visibility. So I'll just try to see whether it is visible or not. I'll try to go there and show it to you. What I've done is I've got 3 LEDs now, red, yellow and green, and this example is also available there in the example section, but I have just made it again. So what we have done is connected ground here, and then the resistances are connected here, then they go here again and they are connected to the LED, and then they go to different pins. The pins that I have taken is 8, 10 and 12. So 8, 10 and 12, 8, 10 and 12. Then on the other side it goes to the resistor and then it goes to the ground. That's it.
Voltage signal is directly applied to the LED first before resistor.
It should not happen, but it's working right now. It should not happen. It should be the reverse.
It is naturally presented in the center point of both the LED and this. So naturally the resistance will itself absorb as a short.
It will, but what Sir is saying is also correct. It should have been that side, but right now it is working. Sure. As I said, I'm more interested into the coding side, whether it is working or not. So
orange, and there are different LEDs which are there. So in the next part, this is all from my side that I'll speak. Now we'll be solving something more. So once you have completed it, I'll get back to it. But let us go for the first one. At least you can hear me out, and then you can try it on your own. Use whatever facilities you have with you, your friends, ChatGPT, this, that, whatever it is, use it. But once you have done it, again I'll repeat, either you should know the flow of the program, or you should at least know the construct of the things, and if both are known, then that is very good. So the next thing is, I want you to use a potentiometer to control the illumination level of the LED. There is a potentiometer there. Use a potentiometer, only one LED, and you need to control it. All the experiments from your side, and in between you'll have tea as well. You sit there only, you can, like ma'am is using, you can give her a connection as well. You can give her a connection as well, and you can also sit. उसमें चार है. Parts. In the first part, you take 24 values of electricity prices during the day. Actually, there are 96 prices in a day. Usually, for energy, whenever you might not be knowing it, I have worked on it, so I can share it. Energy trading happens for every 15 minutes. Every 15 minutes, the rate of electricity changes. We pay it by another method. You have a total unit number and this and that, and you pay it like that. But in reality, what happens is, if you go to the internet, every 15 minutes the rate of electricity changes. To the extent that the minimum rate and the maximum rate has a difference of 3 times, approximately. So in the evening, maybe it is like 10 rupees per megawatt. In the morning, early morning, it may be 3 rupees per megawatt. So, sorry, kilowatt. So this kind of a thing is there. Now in demand response, what we do is, there are different ways of tackling this problem. In developed countries, what do they do is, you do not have energy prices same throughout the day, but they will change it. So if you are consuming electricity in the evening at 6 p.m., you will have to pay higher the price. If you are consuming electricity after 10 p.m. or something, your price would be less. In fact, in Scandinavian countries, in some cases, they pay you to consume electricity. So that would but happen in the night. So the thing is, now we divide that demand response into two parts. One is when the price of the electricity goes above a threshold, I do not consume load. And if it goes below a threshold, so you decide 24 values. Again, I'll repeat, it should be 96, but let us say 24 values. And if it goes above a threshold, the LED should stop. If it goes below that, it should stop. Right? So that is the basic thing that we can do. So you go to that 24 values again and again, and it will stop and start and start, start and start. That's it. Okay. See, basically, what happens is your price in the day, the electricity prices change. So based on the generation and demand pattern. Like you are in Hyderabad, let us say.
Like old cast and
No, not like that. What happens is, we pay it on that is called as block rate tariff, according to how we pay. So it will be like for first 200 units, you have got 2 rupees per unit, plus some other charges and whatever. Then the next 100 units, you pay 3 rupees. Then next 100, you pay 4 rupees. Something like that is there. But in reality, that does not happen. If you go online, there is this website called as IEX India. You can see every 15 minutes the rate of energy changes. So when Telangana buys electricity or sells electricity, it has to follow that rate. And then they generalize it for the public. So we are not going through that problem of higher cost in the evening and lesser cost. But in other countries like US, Europe, even Indonesia and some of the African countries also, what do they do is, if you are consuming electricity early in the morning, you pay this. For the same amount of energy, if you consume that much of energy in the evening, you pay more. So ultimately the price changes during the day. So according to this, what we are trying to do is that in case if the price is high, in the demand response part, if the price is high, I close up the LED, that is the load is cut off. I'll just remove it.
For price I calculate some input.
You have
manual slider we can use in that way.
You can do that only. That is an interactive one. That would be interactive. When you change the price through a slider or something like that, that would be an interactive one. But right now, to the very base level, you take this 24 levels, 24 values, and it loops through it. And if the price goes high, the LED is shut off. If the price is less, and in an advanced level, what you can do is actually this is not demand response. Demand response is divided into 6 parts. In that, one of it is load shedding basically. That is one of it. So when the price goes high, you do the load shedding. Electricity is not supplied. Or you reduce the load by cutting off some of the parts. Another one is you shift the load. So you can shift the load, like in the evening if it is more, you shift it in the morning, night somewhere, so that the total load is reduced. So we can have this one as an extended version. You have, let us say, 3 LEDs. 3 LEDs or 4 LEDs you connected. In the evening, as the cost goes high, you reduce the load. In the night, as the cost goes low, you increase the load. So the LEDs will be lighted. Something like that.
What is 24?
24 hours. But that is again wrong. Every 15 minutes, the price changes. Actually, you could have 96, but if you refuse the complexity, that is happening. 24 means every price, every one value will represent 1 hour. Not understood.
Not complete.
I'll put the values also like this.
Its problem is clear. Writing program with easy.
I'll show you. Let us say I'll just take 12 values. Any 12 values I'll just take. Okay. 3.
What these values represent?
This is energy price.
Energy price.
Price. So I will take here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121,
Okay, so this is applied to the load. How much we are.
Not the something like this. If you get a curve of it, what happens is in the morning, well, you have got 3 rupees per unit you have to pay. 1 o'clock you pay 4 rupees. 2 o'clock you pay 3 rupees. 4 o'clock like that. So what I am saying is that it is going up to 8 here. When it goes to 8, why should I pay 8 rupees? I'll reduce the load. I'll cut off the load. So,
Based on task, we have to
yes,
manage
so
the load.
you are looping through this thing.
Yeah.
As soon as you go to, let's say I put the threshold as 7, as soon as you see 7 or greater, it will stop. Then again from here the LED will start.
Okay.
Then it goes up to here, again it will stop here. Still here, again it starts.
Got it.
And if you have got more LEDs, then you just turn up one LED maybe at 6, one LED at 7, one LED at 8. Generally, this is the normal pattern which is there. It goes very low at the morning, then by 10 it increases, 12 it increases, then goes down, then by 6 again it increases very high. So we will close here, there's keys already arranged outside. We are not closing, means we can come back and again experiment, continue the experiment, but the instruction part is over from my side. And we can have tea and get back and complete it. And those who have completed can also leave. That is it.
When is the